All right, this is Unit 1, Lesson 3. In this lesson, we are going to be solving quadratic equations by factoring. Our content standards for this lesson are that we will use the structure of an expression to identify ways to rewrite it, and we will use the process of factoring and completing the square in a quadratic function to show zeros, extreme values, and symmetry of the graph, and interpret these in terms of a context. Our mathematical practice is that we will reason abstractly and quantitatively. So something that we've already done is we've found greatest common factors of sets of numbers. Hopefully you remember how to do that. If not, you can ask me and I will help you guys remember how to do greatest common factors. What we're going to do now in this lesson is write quadratic equations in intercept form, and we'll solve quadratic equations by factoring. Here's some new vocabulary for this lesson, the factored form of a quadratic equation and the FOIL method. Hopefully you've heard of foiling before. So here's the FOIL method. It's a key concept. FOIL stands for first, outer, inner, and last. There's an example for you to look through here, x minus 6 times x minus 2. Just read through this and you can see how foiling works if you don't remember the process already. Okay, so our first example, what we're going to do is we're going to translate a sentence into an equation. Our sentence here says that we need to write a quadratic equation in standard form with 1/2 and -5 as the roots. So what we're going to start with first is our pattern for a quadratic equation. We're going to start with it in factored form. And since 1/2 and -5 are the roots, we are going to replace the p and the q with these numbers. And notice that it's x minus the number each time. So if we have x minus -5 right here, realize that that's going to become x plus 5 when you have two minus signs in a row. So we have x minus 1/2 times x plus 5 equals 0. Then we need to FOIL, like it says over here. When you FOIL, you'll get this answer. And if you remember back from this previous slide, what they had here for your final answer, give it a second to load. You'll notice that we had our b value is 9/2 and our c value is -5/2. And when we do standard form of an equation, which is the ax squared plus bx plus c, you want to make sure that your a, b, and c are all whole numbers. And right now we have fractions for these two numbers. So when we skip ahead to the next slide, we're going to multiply every term in here by 2, and that gives us these values. So remember before this was 9/2, and this was 5/2, and this was 1. But if we multiply this by 2, and this by 2, and this by 2, and the 0 by 2, because remember you have to multiply, whatever you do on one side of an equation, you have to do on this other side of the equation. Once we multiply everything by 2, then we have whole numbers. We have 2, 9, and -5. So our equation, quadratic equation that has roots of 1/2 and -5 is the equation 2x squared plus 9x minus 5. And again, like always, if you want to check your answer, you can graph that on the calculator and you'll see that it touches the x-axis at x equals 1/2 and x equals -5. All right, here's an example for you to check your progress on. Go ahead and work on this question. Pause the video as long as you need, and when you have your answer, come back and check the answer on the next slide. Remember that you need to have whole numbers as your a, b, and c values, so you should immediately think a is not the right answer. And our answer for this problem is b, 4x squared minus 17x minus 15. Okay, here's another key concept, the zero product property. This property says that if you have two real numbers, a and b, and you multiply them together and you get 0, that means that either the first number or the second number had to be 0, or maybe they both were 0. So just the way that you're going to apply this is if you have something that's FOILed, a factored form of a quadratic, like x plus 3 times x minus 5, that means either this first piece equals 0, or the second piece equals 0, or possibly both of them equal 0. And that's going to apply in the problem that we're going to do next. So this example, example 2, we are going to be factoring. We need to solve 3y squared, or 9y squared plus 3y equals 0. And in order to solve that, we're going to need to find the greatest common factor. So when we look at this equation, what we need to think about is what do these two things have in common? And you'll notice that when they factored, they found that each term had a 3y buried inside of it. So if you factor out the 3y, from the first term you'll be left with this 3y, that's the leftover piece. And from the second term you're left over with 1. That's why 3y and 1 are in parentheses down here. So what that means is that our first factor is 3y. Our second factor is 3y plus 1. And remember that 3y, that was the GCF, the greatest common factor. So that means from here that either 3y is going to equal 0 or that 3y plus 1 equals 0. And then you're just going to solve each of these equations. In the first equation you get y is 0. In the second equation you get y is negative 1/3. So basically that tells us that our answers, the solutions to this equation up here, 9y squared plus 3y equals 0, our solutions are these two y values that we got, negative 3, negative 1/3, and 0. Here's another example. We have 5a squared minus 20a equals 0. So we're going to try to find first our greatest common factor, which happens to be 5a. You'll notice each one of these has a 5a, so we take the 5a out. You're left over the first term when you take 5a out, you're left with a. From the second term when you take 5a out, you're left with 4. Notice if you want to check your work, 5a times a times a is the a squared, and then the 5 is in front. Here, 5 times 4 is 20, and then you have the a. So you can go backwards and check your work and make sure that your greatest common factor is correct. So again, 5a equals 0, and 5a minus 4 equals 0. Notice they left out the 5 here. I believe, never mind, they didn't leave out the 5. This 5 right here, that's wrong. That should not be there. Notice it's just a that should be coming down. This 5 should not be here. I'm going to keep it covered up for now. So we can look, when we have 5a equals 0, right here, you divide both sides by 5, you get a is 0. Right here, a minus 4 equals 0. Add 4 to each side, you'll get a is 4. So your two solutions are 0 and 4. Okay, here's an example for you to check for yourself. Pause the video as long as you need. You need to find the two solutions to 12x minus 4x squared equals 0. When you're ready, come back and advance to the next slide for the answer. And our answer to this problem is 3 and 0. So one of our answers is x equals 3, the other answer is x equals 0. All right, in example 3, we are looking at a problem that is either a perfect square or a difference of squares. And we have the problem x squared minus 6x plus 9 equals 0. So basically, in this kind of problem, you need to figure out if you're dealing with a perfect square or a difference of squares. In order to figure out if something is a perfect square, you want to look at the first term, x squared, and the last term, 9. So for us, the first term is a perfect square. It's the number x times itself. X times x gives us x squared. And 9 is also a perfect square. It's the number 3 squared. 3 times 3 gives you 9. So we see that the first and the last terms are perfect squares. And then we need to check and see if the middle term is going to equal 2 times a times b. So basically what this first and last term being perfect squares meant was that if this first term, this is a, this is c. So if we do, or not, it's not c, it's b. My fault, I'm sorry. So 2ab, 2 times x times 3, 2 times x times 3, that gives us 6x. Does that match up here? Yeah, it matches. This is 6x and this is a 6x. So that tells us that x squared minus 6x plus 9 is a perfect square trinomial. Since this is a minus right here, your pattern for your trinomial is the first thing, the x minus, that corresponds to this minus sign here, the 3, which corresponds to the number we found up here. X minus 3 squared equals 0. Then to solve for this, you're going to take the square root of each side. You square root this, then it's going to cancel with the square. The square root of 0 is just 0. So you have x minus 3 equals 0. Then you add 3 to each side, you get x equals 3. That's your answer for the solution to this problem. If you're not sure, if you don't remember the pattern for a perfect square or a difference of squares, go ahead and ask me and I'll put the formulas up on the board for you guys to look at for this section. Okay, part B of example 3 says we need to solve y squared equals 36. Hopefully you can see an answer to this very easily. What number squared equals 36? That's really all you have to think about for this problem. Here obviously is a typo, this should say 36. So what you want to do first is you are going to bring the 36 from the right side over to the left side. It's important when you're solving these problems that your right side is always 0. When you do that, you have y squared minus 36 equals 0. Notice that the first term is the number y times itself, y squared, and the second term, 36, is the number 6 times itself. 6 squared gives you 36. This is a difference of squares. It's a squared, the first thing squared, minus b squared. So our a is y and our b is 6. The way you factor that is going to be a plus b, so y plus 6 times a minus b, y minus 6. And then you're going to solve each of these equations. Y plus 6 equals 0 and y minus 6 equals 0. And obviously for here, this first equation, you're going to get y equals 6. And the second equation, you're going to get y equals 6. First one, negative 6. Second one, y equals 6. So our two solutions to this equation are negative 6 and positive 6. Again, this is a typo. This should say 36. Here's your form, a squared minus b squared. We factor, we solve each equation. We get our answer. All right, here's an example for you to check on your own. The first thing you should think about is this a difference of squares, or is it a perfect square problem? So pause the video, work out the problem, find your answers. When you're ready, come back to the next slide for the answer. And our answer to this problem is 8. There's only one solution to this equation. Okay, we're going to stop the video here and pick up with a new video for example 4.